We're gonna introduce our next speaker here, Dr. Karyn Havas with Pipestone Research. Dr. Havas is a veterinary epidemiologist for Pipestone in their research division. Her background of specialty is transboundary animal diseases, and she currently has projects related to cost of disease in the wean to finish sector and antimicrobial resistance trends in swine production. Dr. Havas is going to talk today about an overview of Salmonella isolates and resistance.
Okay, so Salmonella isn't a transboundary animal disease, but we're doing a lot of work at Pipestone to take a look at the pathogens that circulate and the cost of them and the antimicrobial resistance and all of these things. So as an epidemiologist, I get to dabble in a lot of different areas. So what I'm going to do today is just talk to you about, through these different projects, what we found, particularly with the serotypes, is going to be the focus. All right, so we have two different sources that we used, and one is a project on AMR, antimicrobial resistance monitoring, where we spent about 3 years collecting samples from pigs' intestines or fecal swabs. So for the first 2 years of the project, we collected a whole bunch of tissues, and most of our Salmonella isolates came from the intestines, and they came from the intestines of either substandard pigs, so belly ruptures, fallbacks, things like that. So not keeping up with their peers or having a non-infectious issue, or sick pigs. So often an infectious issue and often treated. So those would be the first set of samples. Now the second set of samples, as you can imagine, that's a lot of work to go in and sacrifice some pigs and take all those samples. So we had to make it a little more efficient, because another goal of this project was to see if we can do efficient AMR monitoring. So we ended up taking 4 healthy pigs and taking fecal swabs from 4 healthy pigs. So a little quicker, right? But a slightly different sample type. So the intestine was the cecum and also some of the small intestine. And then the fecal swab was clearly the end of the colon, right? So those are the two sources, primarily I'll talk about today, that we took from breed to wean farms or sow farms in the wean to market side. We also did this composite fecal testing where we took an environmental 3M swab and swabbed it all over the barn. So in the farrowing room, in the gestation room, in the loadout, in the wean pig room, in the GDU, and we did that one as well. But with that particular method, we followed NARMS methods to culture, and we did not serotype those. So I won't summarize those today. This sampling was done twice a year, and obviously on the sow farm doesn't change, so we did sampling on the same sow farm twice a year. But in the wean to market side, we did by enterprise. So one time we might have gone to barn A on Farmer Jones' site, farm A, and the next time we went to farm B, all within the same enterprise, but not necessarily the same site. So just that's something to consider. These samples were pooled. So if it was a sick pig, the samples were pooled within the sick pig. If it was a healthy pig, they were pooled within the healthy pig. And then they were cultured following standard techniques, run on a MALDI-TOF to identify the isolate that was found on culture. And from there, we did antimicrobial susceptibility testing. So I'm going to share some of that MIC data. And so that MIC data is from Thermo Fisher bovine porcine 7F plates run on the Sensitizer system with Swine software by South Dakota State University. It had nothing to do with that, right? So South Dakota State University did all that work for us. And then anything that was a Salmonella got sent to NVSL, and they sent us serotyping results whenever they could. So that's our first source of data. The second source of data is a project that we're currently doing. I guess I should also say, this project was funded by National Pork Board and the Foundation for Food and Agricultural Research and Pipestone. And this project is funded by the Swine Health Information Center, but mostly by Boehringer Ingelheim. They're putting in the majority of the funds. So this one is underway currently, and we're going into barns, and we're going in at 2 times during the growing period, and we're following groups of pigs. And these pigs are placed disease negative for MHIO, influenza, PEDV, and PRRS. We don't follow the bacterial health of them. That's a little more complicated, but we know they're placed negative for those other viruses and mycoplasma. So, but we are testing for Salmonella and Lawsonia as a part of a co-infection evaluation, and we're doing something a little different here, and this was set up with Iowa State University. So we're taking 25 grams of feces from 6 different pens each time we go at 8 to 10 weeks of age and 18 to 20 weeks of age. And we're culturing off of 25 grams of feces, and that gives you a much higher sensitivity. So that's why we're doing that. And I have those results through the end of last month. So I get an update every month, so that's my most current results. And again, any isolates are sent to NVSL and serotyped. There is no antimicrobial susceptibility testing for this data though. So I won't be able to show you any of those squash diagrams. All right, so when basically we cultured, we found Salmonella, we serotyped, and these are the serotypes. And there's a lot. There's a surprising amount. So in our intestinal, do I have a buzzer? No, not very functional one. In our intestinal samples, but I hit all the buttons. In our intestinal samples, we have a large selection of different Salmonella serotypes. And the ones in purple are the most common. But far and away, the monophasic typhimurium wins. 41% essentially in our intestinal samples. Typhimurium is also on there, and they're kind of, you group them together. The monophasic is a variant of typhimurium. So the leading cause of Salmonella isolates, because they weren't necessarily all sick pigs, and if they were sick, they weren't always sick from Salmonella. It could have been S. suis or A. suis or GPS or any other cause. So 41% by the monophasic typhimurium. That was followed by Salmonella derby at 9.7%, and then typhimurium, the traditional old school typhimurium, at 8.4%, and infantis at about 7%. Those were the top. And then there was a drastic fall off in percentages or counts of those isolates. Then when you look at fecal swab, you see a similar trend. You don't see quite as much monophasic, right? It's almost tied with the traditional typhimurium at 15.6% versus 14.8%, but still the leading cause of Salmonella isolates, or leading finding of Salmonella isolates. And then derby is still quite high at 13.5%. So a little more evenly spread out. The percentages are more equivalent in our fecal swab sampling that happened in the last year of that AMR monitoring program. And then it's this other. So this other is we took a lot of different types of samples. We took some liver and lung, we took a brain swab, we did all these things. So we sometimes isolated Salmonella from these other tissues. So that's what this other is during those first 2 years. And again, a huge amount of variance. And on this one, once again, the monophasic wins, 31.12%, and then typhimurium was 7.9%, infantis was 5.1%, derby was 9.2%, and then you had a fair amount of agona at 4.3%, and then the rest were very small counts. So now we see agona in the game, but primarily we see a large amount of monophasic, a large amount of typhimurium, and derby is on there as well. So yes, some public health concerns, obviously. So what about the cost of disease project? When you look at the cost of disease project, we've been doing this for we started in January. It's now August. We've sampled, we've done 2 samplings on 45 sites and 1 sampling on 60 sites. So it's a process to follow the groups through. It takes some time. So when you look at the Salmonella at 8 to 10 weeks, in the cohorts where we have 8 to 10 weeks, once again, the monophasics win. Far and away win. About double to agona, which is the follow-up. And this is the wean to market side. And then in 18 to 20 weeks, you see the same trend. There's not quite as many as you can see. It's 43 isolates versus 29. And the monophasics, once again, are the highest option. And then and then you see the agona and the derby. So on both sides, it's monophasic, agona, and derby, slightly different variations, but the monophasics win. Now, when you look at just how many sites were positive, 60% of our sites had Salmonella, using this highly sensitive culture technique. Typically, you don't collect 25 grams of feces and send it into a lab, right? So typically, you'll take a fecal swab or a small sample. So it takes coordination to be able to do this, and it's given us some additional sensitivity, I believe, that's been helpful. Now, 10 of these sites had more than 1 serotype isolated. So we found often a monophasic or a derby or a combination of a few different serotypes in one location. Of the 23 of the 45 sites that were sampled twice so far, that's about almost half, about a little over half were positive for Salmonella. And again, 7 of these sites had more than 1 serotype. So we have a fair amount of salmonella in our farms, and I don't think anyone's surprised, right? There's salmonella everywhere. But this is what it looks like, and the monophasic is what shows up. And I circled them just to make it easier to see. Okay, so squashtograms. I learned this word this past year, squashtograms. I kind of love it. Whoever named this is great. But these are the minimum inhibitory concentrations from broth microdilutions from the bovine porcine 7F Thermo Fisher plate. Right? So we don't have breakpoints. We can apply human breakpoints, but should we really do that? So I don't use breakpoints when I talk about our animal samples that aren't evaluated with the NARMS plate. But I do think it's useful to look at the distribution of MICs. And there's a color coding that's going to occur. So let's walk through this color coding because it's going to be important. If it's red, that means it's at the high end of the MIC distribution. So greater than the highest end of the MIC distribution tested. So we have, and I also didn't indicate, you'll notice that I'll leave out some of these, like clindamycin and spectenomycin and tulathromycin and tylosin. Salmonella has some resistance, some inherent resistance. So if I don't circle any of these, it's because there's already inherent resistance, and I just don't want to bias the conversation by discussing that. It makes it more complicated. So yes, they're at the high end of the range, but it's expected because it's just they have a natural resistance. It's not an acquired resistance, right? So something to keep in mind. So we see our monophasics from our intestinal samples. I didn't look at the others because I needed some power, right? There's a great deal at the high end of the MIC range for ampicillin, for penicillin, for tetracycline, for thiamulin, for the sulfas, trimethoprim, and sulfa without trimethoprim. And then we have a few where the majority, and this is how I classified it, by greater than 50%. So this is, right, this is a little crude. If it had greater than 50%, it got circled. And a few of them had the greater than 50% in the middle or just below the high end of the range, but not at the greater than the high end of the range. And then you got your fluoroquinolones hanging out with more than half of the isolates at the low end of the range, which is good. We like that, right? That's positive. So that's our monophasics. Not really surprising given what we know about monophasics, right? A lot of them have a lot of resistance, and our monophasics are no different. For the fecal swabs, it was essentially the same pattern. Essentially the same pattern was seen. The majority of isolates for this set of drugs was the same as before. There was no one really in the middle, and then you had the fluoroquinolones at the bottom end of the range. So, okay, we know we have resistance, probably, right? We don't have breakpoints, we don't have ECOFs, we don't have all these things, but we know that they're at the high end of the range. There's probably some resistance problems. What about and here's our other tissue. You can see not as many samples, only 94. Very similar patterns, a couple in the middle, and the fluoroquinolones at the bottom. So similar patterns for monophasics, whether it's a fecal swab, an intestinal sample, or even from other tissue. What about just the old faithful typhimurium, not the new variant that's taken over? A little less resistance, right? There's just you don't see it with ampicillin now. You don't see it with thiamulin now. So you have a little less resistance that shows up. You have more with the majority in the middle of the range, which is better. And you also have more with the majority at the bottom of the range. So the traditional typhimurium that we see, at least in our fecal swabs, is slightly different than what we saw with the monophasic. And the intestinal, same story. A little less in terms of the low end of the range, but still pretty similar to what you saw with the fecal swabs. And the others, once again, I start to sound like a broken record, but same pattern. So between the monophasic and the traditional typhimurium, there seems to be less isolates at the very high end of the range for the traditional typhimurium than there is for the monophasic. Now let's compare that to some other groups. So remember that color coding? Still applies, but now we got blue. So I threw in the blue because now I'm comparing NARM's data. This isn't my data, this is from NARM's, it's from their dashboard, and saying where it's different from my data. So that's what the blue means, because I already took red, so I had to come up with another color. All right, so I circled the swine so you could clearly see what the swine were, and everything else is cattle and chickens and turkeys. So there's a lot of similarities between what we found, right? So the majority of for the monophasic typhimuriums, ampicillin, the majority are resistant. Now they're using the word resistant because they use breakpoints. They use NARM's patterns, and the FDA has established breakpoints. These breakpoints are really public health breakpoints, though. So this isn't talking about swine breakpoints. So now I'm trying to compare being at the high end of the range to NARM's breakpoints. So there's a limitation there, but to be very transparent, that's what I did, to try to make some comparisons and start to have a discussion. And it's pretty similar. Chickens are different, but they're chickens. They're evolved from dinosaurs, so they're going to be different. What can you do? But overall, we see similar patterns across the board. Yeah, there's some difference with tetracycline in cattle and chickens compared to swine and turkey, and all the sulfas are quite low here where we had a high. If you took that one well that they use for sulfas on the bovine porcine plate, you get one well, the 256 concentration. We had the majority on the greater than to that well rather than in that well. So there's some limitations to our testing of those sulfas. So that might be the difference there. Typhimurium, you see similar relationships, except in this data for typhimurium, the majority of isolates were resistant to ampicillin, and we didn't see that. We saw the opposite. There was no majority at the high end of the range. Cattle were a little bit different otherwise, but other than that, it aligns with what you expect, right? Our data has a similar trend as the NARM's data. So I said, okay, well, that's good. That's NARM's, that's livestock. What's going on in Europe, right? Because Europe's doing a lot of stuff. And I will just put all these up to make it a little easier. Oops, too fast. And so there's some differences. Their trends there are a little different than ours. The blue circles are a little different than ours. And others, it's very much the same. It's very much the same, but there's a few areas where it's a little different. But overall, they see high levels of resistance. They use resistance here, where we see high levels of potential resistance. They see low levels of resistance, and we see low levels of potential resistance, with some differences with sulfas. They had a higher amount of resistance with enrofloxacin than we did, and with ampicillin in the non-monophasic typhimurium. But their ampicillin in the non-monophasic typhimurium match NARM's, so that could say something as well. And when you start to look at some of the science behind this, and you start to look at why this is happening and what's there, we learn that there's a lot of resistance genes in these particular types of typhimurium, and monophasic versus traditional. And you see a lot of tetracycline resistance genes. You see a lot of sulfonamide resistance genes. The aminoglycosides I didn't find as surprising because there's that natural resistance that's associated with them, but I could be wrong about that. But basically what I'm trying to say here is a lot of these variants are known, and it's been studied over and over, to have this resistance pattern. So we don't feel as though what we found is unique. It's just what is shown about these particular types of Salmonella variants. So basically, what we've learned is we have what everybody else has. We have the trends that exist in the world. And it's good to know, right? And it's good to know because these are public health concerns, for one. And nobody wants to be worse than anyone else, right? Like particularly public health concerns. So swine have monophasic Salmonella. It's well established. The resistance components to it are well established, and we've been able to show that, yeah, we can go on farm and find that and look at them and find the same patterns as everyone else. So we feel like that's informative to some of the programs that might be coming down the pike in terms of Salmonella monitoring, because we have conversations on occasion. Someone will call and say, hey, we know you guys are doing these projects. Can you tell us a little bit about what you're finding? Because there's not a lot out there. And it's true, there's not a lot out there. The lymph node study is brilliant. I'm so glad to see it because we need this kind of information. And our information aligns pretty well with what's found, I just learned, what's found in the packing plant. So that's good to know. And so between our two types of programs, one where we're taking pen samples and one where we're taking a fecal swab or intestinal samples, we have similar trends. We have similar trends with similar resistance patterns. And if you're unaware, this monophasic typhimurium's taken over. So it's not just Pipestone or this set of plants. It's replaced the traditional typhimurium as the leading cause of, or leading isolated salmonella in the swine industry. And that's true not just in the United States, but it's also true globally. And yeah, it's a public health threat for sure. We can't ignore that, absolutely. But it's not just a swine problem, it happens to be a cattle problem and a chicken problem. And we tend to be heavily involved in this problem, but it's a global problem as well. So sometimes it's nice to confirm what we already know and know that you can go on farm and do a good surveillance system and find what's expected. And I think we've done that. I think we've shown that there's ways with either our cost disease or the AMR monitoring to really look for salmonella and keep an idea of what's out there and what's going on. Because we need that information if we're going to inform regulators on how to do a control program and what is really going to be the issue, rather than go in blind. So that's why we were excited about this opportunity to come and share, not because we're different, but because this is so important to understand that these are the trends we see, and they're the trends seen everywhere, and we're showing those again. So a whole bunch of references, and then a number of people to thank always, so a whole list of folks here to thank, and I'll take any questions you may have. I think that was probably pretty quick.
Questions for Dr. Havas?
Perfect.
We have to give people a minute to think. I knew it, yes.
I'm curious about your vaccine strategies. You vaccinated at all for salmonella?
So there is some vaccination that's done, and it's often in the wean to finish sector. And so Pipestone, we don't own any pigs, and we manage sow farms. And we sell those wean pigs to our grow to finish side, and we'll consult and give them what they need. So some of them vaccinate, some of them don't. It's not consistent across all of these particular farmers. And the vaccines are for cholera suis, as we know, right? So, yeah.
You mentioned something about the regulators going back to the live farms and making judgments based on what they find there.
So would you like to know more? Yeah. Yeah, so we work a lot. One of my jobs at Pipestone, one of my favorite jobs at Pipestone, is to talk to our government entities and talk to them about farming and what that's like and how we can work together. So we often have folks out. So we've had folks from the CDC and the USDA, and because of the salmonella and poultry issue that's going on, they've asked, they're like, well, what are you finding for salmonella on farms? And at the time, I hadn't summarized this data, so I couldn't answer that question. I was like, well, we're finding a lot of things, right? We've 20 plus different serotypes. But they're already thinking about how are we going to implement and what do we need to implement against and how is that going to work and how can we, and they can only do it at the plant, but the plant can then enforce the farm. So it's often going to be through FSIS and it's going to be at the plant, but they'll create a requirement for the plant that will impact the farm, and then the plant will enforce it that way. And then the CDC is interested because of, obviously, the human health concern. Because salmonella, their control of salmonella has been pretty unsuccessful for over 20 years. They've tried to drop it, and they haven't, so now they're looking for new ways to do it, and they're pretty gung-ho on making that happen. I can't blame them, right? Nobody wants to have a steady state of disease and not drop it down, but trying to have those conversations about what is actually out there. 3 months ago, I hadn't looked at this. And now I can. Now I can say, yeah, we have what everyone else has. And no, monophasic's not great to have, but it's not surprising. And now you've been on our farms and you understand how they work. Let's work together to come up with the best plan to deal with this. versus be like, I don't know what we have. Maybe it's not even a human health concern, and of course it is. So, yeah. Yes, sir.
I've described myself as a recovering salmonella researcher, so I did a lot of
Oh.
culturing in the 1990s in North Carolina. And that stage, what you've seen with the monophasic was all of a sudden this thing
Coming in.
appears, and we had the same issue globally and in multiple species with something they called Salmonella D2104 back at that time, and it was a typhimurium variant.
Okay.
And it was predominantly the 5 negative Copenhagen variant. So in your last slide, you had the traditional typhimurium and the 05 negative. So that was sort of going to win Western civilization in the 1990s. In fact, in Denmark, they depopulated farms when this variant was on it. So I'm just curious with actually both the last two presentations, whether you differentiated with the typhimuriums into the 05 variant or not the 05 variant. And the reason I'm doing it is because there was panic stations about the emergence of this new variant, and it's disappeared. And it's disappeared not just in swine, but in many places over 20 to 30 years. So what we're seeing with the monophasic is sort of not really like a new thing. It's like a replay of things. If you look far enough back in Salmonella, there's always these waves of things, serovites that appeared out of nowhere. So I'm just sort of, how much do we need to panic? How much do we need to change? But I was just curious whether people were even bothering to look anymore at that distinction.
Well, for us, we primarily took whatever NVSL serotyping was. So if it wasn't in their algorithm to go further, we stopped there because that was just how it went. Yeah.
Historically, they would have made that distinction.
Yeah, this was the extent of the data we got back from them. Yeah, but that's the best answer I have.
Karyn, what was the prevalence overall of Salmonella by site? Like any Salmonella?
That's a great question. I do not know. Yeah, other than the cost of disease, I have it summarized, and I could get it for you. I will email you that. Yeah. I have it somewhere, but I would say about 25 to 30% of our samples were positive overall.
Would you expect to see much variation from that as to both either?
Variation from what?
25%.
It was pretty consistent over 3 years at about 25 to 30% on our AMR monitoring were positive. We're 8 months into the cost of disease study, which is a different sample type and very different approach. But it was pretty consistent year to year. So.
Did you look by season?
We didn't see any seasonal differences in a lot of our stuff.
Okay.
So, but
Okay.
we did look at it by season for other things, and there wasn't a lot of variation, but it also kind of fell apart. Like we didn't have enough isolates to have any power when you broke it down by season, and so it really started to kind of disintegrate as you did that.
Okay. Any other questions? All right, thank you so much.
Yeah, sure. Thank you.